welcome to this video on Azure Advent Calendar. I am Ezhilarasi, product consultant of Serverless 360 and complementary tool to Azure portal. I am so excited today to talk about Azure Service Bus. In this session, let us have a closer look at the advanced features of Service Bus and how does it fit into the real world business.
I would be glad if you stay connected with me on my Twitter handle. And let us start off this session with a closer look into the real world business. So present real world business applications are too complex, which demands asynchronous programming, and the users are so demanding they would want to feel as if they are the only one using the application. So we need to build real world business applications which are reliable, scalable, secure, and whatnot. And here is where an most reliable and secure messaging service like Azure Service Bus becomes integral. Let us have a quick overview about Azure Service Bus and then get deeper into its advanced features which map on exactly to the real world business scenarios. Microsoft Azure Service Bus is a fully managed enterprise integration message broker. And this can help me in decoupling the applications and services. Service Bus offers reliable and secure platform for asynchronous transfer of data and state. Data can be transferred between different applications and services using messages. So when I mean by decoupling applications and services, my publisher and subscriber need not be online at the same point in time. When I have a single subscriber for my message, I can choose an service bus queue, wherein when I find my subscribers to be growing more than one, then I have a option to choose my service bus topic, which can support one-to-N relationships. So as we said, data is transferred between the applications and services using messages. What is a message? A message is a binary format that can contain JSON, XML, or just text. And this transfer of business data is so common among any real-time business application that we deal with. Say, for example, when we pick up an e-commerce application, sales or purchase orders, inventory management, item procurement, these are very common in a typical e-commerce scenario. And when you drill down into any business application, messages would become an integral part. And there is where and messaging service, which is reliable and secure like Azure Service Bus, becomes important. What is a namespace at this context? A namespace is a container for all your messaging components, and multiple queues and topics can be put together within a single namespace. And namespaces often serve as an application containers. So queue can send and receive messages. Say like I can send messages to the queue and my client application can receive messages from a queue or a topic subscription. And you can ensure ordering here, and you can build complex business applications by making use of the advanced features these service bus queues and topics have got, which is going to be the focus of this particular session. Let us look at some of the key capabilities of Azure Service Bus as we proceed further. First one to pick up, topic subscriptions. As we were just discussing about multiple subscribers on my messaging service. So let me bring up a real-time scenario here to make you better understand where would we need a multiple subscriber scenario. Say, let us pick up an aggregator portal like a TripAdvisor or Make My Trip, wherein when I look for hotels at a specific location, I get rendered with multiple hotel listing. When I proceed to book I provide the details about my duration of stay, number of people, how many rooms I want, all that are picked up by my TripAdvisor portal, compiled as a message, and it has to be pushed into the specific hotel to confirm my booking. So what do I look at the background is a topic with multiple subscriptions and each of the subscription being specific to my every single hotel. So let me show you in real time how do I create an topic with multiple subscriptions like this, and how do I ensure that how do I define my subscribers receive the intended message only. So this can be achieved with the help of topic subscription rules. Let me quickly show you how do I create my topic within my Azure portal. So here is my Azure portal. I have got a resource group that represent Azure Advent Calendar, and I have got a Service Bus namespace, which we just saw. It is a container within which I can create my queues and topics. And I can very easily create my queue or a topic with in the Azure portal itself. I can provide a unique name to my topic. I can enable certain properties that I found to be relevant to this. I can specify a size of the topic and create it. And within a topic, I already have a topic created. Let me show you. A TripAdvisor is a topic with 1 GB size I have created for this demo, and I have created multiple subscriptions within this. So as you see, the number of messages within each of my subscription in real time will not remain the same because it depends on the number of bookings I get for each of my hotels. And how do I manage to define which message has to get into which of my subscription, because I might ultimately have different client applications built on various technologies running in various platforms, listening to each of this subscription, which will receive the message and process my booking request. So here is where defining a topic subscription rule comes into picture. So what is a topic subscription rule? Through a rule, I can define how should I which message should get into my topic subscription. So which can be a filter based on the message property or the message system or custom property that it holds. Okay, so to start off with, like the defining a rule is straightaway not possible through the Azure portal, but we do have .NET SDKs which are exposed, and you have a very good documentation that clearly tells us how do I define a rule. And to connect with an service bus entity, you will need an shared access policy or a connection string of my service bus resource, which can be retrieved from the Azure portal itself. You can create an connection string with appropriate permissions, and you can use this to connect to your service bus entity. So today for this session, I'm going to use our tool Serverless 360, which has been built to achieve certain real-time requirements like defining my topic subscription rules. So I'm going to get into one of my business applications that I have represented in Serverless 360, through which I would show you how do I define the topic subscription rules and achieve my business need of auto filtering the messages. So you see here the TripAdvisor topic, which we just created in the Azure portal, which has got multiple subscriptions within that. And here I define a rule which says any message which contains a custom property called target, which is equal to Baba Homes, should get into this particular topic subscription. So when a message is sent to the service bus topic, which is TripAdvisor, it is going to check for its custom property and then put it into the appropriate topic subscription. So let us get into one of my topic subscriptions and verify if the message has got the intended property or not. So I have got into one of my topic subscriptions. I am retrieving few messages, and I get into the message details and I find that it has got the intended target. Yes, so this is how I have achieved auto-filtering the messages into the respective topic subscriptions using topic subscription rule definition. Let us get into the next advanced feature, dead lettering. So dead lettering is a key capability of Service Bus which makes it really powerful. So when we talk about the reliability of the system often, it is necessary to hold those messages that cannot be delivered to any receiver at any point in time. So here is where the message dead lettering comes into a picture with great importance. So any service bus queue or a topic subscription would have an active end wherein you have the active messages that are pushed into the queue flowing in, through which the client application can listen to this active end of the queue to pick up the messages and then process. But what if the message is undelivered to end receiver? This could be due to the client application was offline or it was not available to process the message. And the message is defined with a specific time to live, which would cause its time to live expire. And what would happen to this message? It would get into my dead letter queue if I have enabled dead lettering on expiry. So when I create the queue, I have an option to enable dead lettering. So once that is done, I can be rest assured that if my client application has not processed by message, it would end up in my dead letter queue. Yes. So what are the different reasons why my message would get into my dead letter end? When the header size of the message has exceeded. So 256 KB is the maximum size allowed for a message that gets into my service bus queue. What if my upstream application, which is pushing message into my queue, has pushed a message with a header size beyond that? It would get into my dead letter queue. If the time to live of a message has expired because the client application failed to process it, it would end up in my dead letter queue. If I am dealing with an session enabled service bus entity and I have pushed a message without a session ID, that would also cause it to end up in a dead letter queue. And a maximum transfer hop count. A service bus queue has got an interesting property called auto forwarding. So when you enable auto forwarding, whenever a message comes into this queue, you can automatically push it to another service bus queue or a topic. So one hop is one forwarding. So if the message is maximum transfer hop count is set to 4, and if it has been pushed or hopped more than 4 times, then it will ultimately end up into the dead letter queue. Say we just saw what is an topic subscription filter. If a message filter evaluation fails, then we'll also get into a dead letter queue. Apart from these predefined reasons, and client application can also specify a custom reason when it is dead lettering a message, which could be like an expected parameter is not found as a part of the message. Or let us pick up a scenario in e-commerce. Say an order has been placed for an item, but unfortunately when the order is getting executed, the item has run out of stock, or the supplier has stopped supplying this particular item. So this would force the client application to push the message into a dead letter queue. So it's all good. Yeah, we can find the dead lettering to be playing a critical role in solving a lot of real-time business needs. But what will happen to these dead letter messages? So let me show you, give you an visibility on to your dead letter messages with the help of the same application service bus queue. Serverless 360, wherein I have got an order processing queue which has got a number of dead letter messages. So let me retrieve a few dead letter messages in peak lock mode. So the message might get dead lettered. Few of them are dead lettered due to a reason like time to live expiry, because my client application failed to process these messages when they were in the active queue within the time to live off this message, and this has pushed them into my dead letter queue. Say maybe I can take an action like I select multiple of them and resubmit them back into my same queue itself, enforcing my client application to pick them up and process them right now. This is one action that we can perform. Or say if I find that my messages has been delettered with an reason, say like out of stock, and these messages I do not want to retain them. So I can retrieve them in defer mode to take action like I just want to get rid of those messages which has been out of stock. Say I can choose to select all of them and then purge them off. So such dead letter processing can be done like with the help of a tool like Serverless 360, or you can manually process them by connecting to your um, business applications using the credentials. So this is how a dead lettering can play a critical role in achieving a real-time business need. Next comes messaging sessions. See, if you want to realize an first in, first out guarantee in Service Bus, then you will have to enable sessions in your Service Bus queues and topics. So this will ensure that the messages are rendered in the guaranteed first in, first out order. So let us pick up an railway ticket reservation system as an example here. Say my queue keeps getting reservation requests for various classes, say like first AC, second AC, or third AC. Yes, and the messages keep flowing in because it's a real busy system which has got enormous number of requests from users across the country at any point in time. And I want to ensure that my specific class request gets into a specific session and they are handled strictly in first in and first out order. So I can achieve these at ease with the help of enabling sessions on my service bus entities. Let me show you how this is being achieved with the help of like how do I actually view this in my service bus queues using our tool Serverless 360. Say I have got a queue to which I have enabled its session at the time of creating my queue. So I can view the properties of the queue at any point in time here. I can find that required session is set to true, which can be set at the time of creating my queue. Say if I am creating a queue, see, this is my service bus namespace wherein I'm creating a queue. At the time of creating my queue, I have an option to enable sessions. That is it. Just if you enable this, it will ensure first in, first out guarantee on your queue. So with this, let me get back to the portal wherein I was showing you how do I view these messages there. So I'm getting into this particular queue, receiving few messages, say 25 messages. And let me show you how they are strictly processed in order. So I'm retrieving the messages filtered by a session ID, which is equal to my one of my session ID, say 1. As you see, the messages are received strictly in the order of their sequence numbers. And this is how they would be processed. So when I enable session, my specific session receivers can mention the session ID and retrieve only those specific messages, and they can be ensured that the messages are processed in order. Duplicate detection is another interesting property that service bus queues offer. Say when I have to define this property, I will have to deal with two parameters here. So when I create the queue, will have to enable duplicate detection, say which I can do at the time of creating my queue in the Azure portal. Say enable duplicate detection will do that. The moment I turn this property on, it also asks me about a duplicate detection window. That is how this property behaves is like, say imagine a real-time scenario wherein the business might fail due to any network failure. Say my publisher is pushing a message with a specific message ID. And some network error happens. So now my publisher is unaware, it's or not sure whether the message has been delivered or not. So it has been configured with certain retry policies, which pushes the message again with the same message ID. So what this duplicate detection enabled queue will give a comfort is like it will send an received successful confirmation, but it will ignore the duplicate message. So it is now intelligent enough to understand when a message needs to be ignored. And this decision is made purely based on the message ID. So when I am dealing with an duplicate detection enabled queue, I should ensure that the message ID is properly constructed, so that will inform the queue to make a decision on whether the message to be ignored or accepted when a network failures like scenario happens. So creating a duplicate detection enabled queue is quite simple. And like as we said, you can enable this property and define a duplicate detection window. So when we say the window is for few hours, so the message ID received will be retained in a temporary location for this duration of specified, and any incoming message ID will be compared against this message ID that has been retained to make a decision of whether the message should be retained or rejected. Yes. But at times when I am dealing with an duplicate detection enabled service bus entity, there could be a need for me to reprocess these messages. Say I have an service bus queue with the duplicate detection enabled. Say, let us see how it ignores the incoming message within the duplicate detection time frame window. So as I find here, I have an service bus message which has been pushed in and with a specific booking ID, and this is the message ID. And using serverless 360, I'm going to send a message with the same ID to this particular queue using an activity. And in this activity, I have defined to send a message with a specific ID. So in the system properties, I have given the same message ID just to ensure that the message is rejected. So when I again get into that particular entity queue, and I pick up that specific queue, I still find the number of messages to be 1 because the message has been ignored. And now this message has come in because the duplicate detection time frame window is beyond the time that I have mentioned. So duplicate detection along with the time frame window definition will ensure that within the detection time frame window, the message will never be allowed to duplicate, and the decision is purely taken based on the message ID. But if you would like to enforce this message with some modified content is pushed back into this same queue with an same message without any message loss, then you have an option to resubmit to the same queue by regenerating its message ID, because as we said, it is purely based on the message ID and not on its content, and then proceed to resubmit through the tool that we are dealing with right now, Serverless 360. So getting into the coming to the end of this session almost, like here are few tips and tricks that we will have to keep in mind when we are dealing with the service bus entities to make the most use of them. So when you choose the properties or the advanced features of service bus entities, fit them directly into your business application and choose the appropriate properties so that they really fit into your business demand. And use a push model instead of a pull model. Say like when you have a logic app listening to your service bus queue. So you can create an time triggered which will look for any incoming messages in your queue, or you can choose an service bus queue triggered logic app which will react or get triggered only when a message gets pushed into your service bus queue. See if this logic app is replaced by any of your custom cloud application. Then bring in an event grid in between. This event grid can help you achieve an pull model instead of a push model. So the client application need not keep looking into your queue, keep polling to your queue, which will in turn have an impact on the cost that you spend on your application. So instead, trigger an event to your event grid as and when a message comes into your queue, and this event grid will take care of triggering your client application to receive message from your queue. And use peak log for accessing a group of messages. When you have a complex filter in your topic subscription to auto filter your messages, be aware that it is going to require an adequate processing time. So always be sure about this will have an impact on the processing or efficiency of your service bus entities. So create appropriate filters to auto filter the messages that you are expecting to get into your topic subscriptions. And this brings us to the end of the session.
Thank you for listening to me. Wish you all a Merry Christmas and a very Happy New Year.